about any details about AI, how it works and such. In general, I guess all audience seen it and knows what it works, but this is my favorite slide when it comes to AI, how I usually explain it. If you take classical programming approach, like to figure out that this is a dog on this picture, yeah, you would have a lot of problems writing some algorithms and such. And with AI, it's actually pretty simple. You can train your model with some dog pictures and then figure out like, okay, yes, this looks like a dog, providing some other picture of dog that model haven't seen it yet. And after all, like a bunch of those tutorials you see online is about cats and dogs, like when you are starting to learn about AI. But today I decided to do something more fun. So I took the Lego minifigures, which you will see in a few minutes. I got them also over here, and we will train our model with that. And regarding AI, Microsoft gives us a lot of things out of the box. So with this cognitive services, every developer can start building a lot of interesting stuff. You've seen some things today, and I'll open this link. So in cognitive services, there is a lot of those services that you can use for decision, for language, speech, vision, like computer vision, custom vision. Those are things we will touch upon. And there is a lot of other services that are already built and ready for you to use. I highly suggest that you check this out, because like you can easily add AI capabilities to your application. And switching back to slides, I would like to show first the computer vision, and then we will move into custom vision. And as Microsoft nicely described it in one super short sentence, this is an AI service that analyzes content in images. And following this link, on the computer vision page, you can see description and some examples. And over here you have one example showing some people on the station with the train passing by, and that image is analyzed. And on the right side you can see detection of some objects, like this object defined in this rectangle over here is a person, and there is some confidence how sure this AI is that this is a person we talk about. There are different tags described. There is a description, something that AI is trying to pull out of the picture, like what it is actually, people waiting at the train station, and many other properties. So this is one model for general use. This is one model for general use that we could we could use to detect some standard objects in a picture, like detecting train or detecting the table, chair, and so on. But what if we need something for custom use? If this is not sufficient for what we need, then we should use the custom vision. And this custom vision you can access on the web page Custom Vision AI, and this is where we will start working. So please open the web page. And as Microsoft described it, this is visual intelligence made easy, and it really is made easy. And you can start start creating your models without going deep in some math and science behind the model, how it actually works. In a simple way, you can upload images, you can train, and you can evaluate images for results to see what's in those images. And for this session, I prepared also the GitHub repository on the following link, github.com/gvuksic. That's first letter of my name and my last name, and then /Azure Skåne AI Day. If you open that repository now, you can see over here on the top. In it, you can find several folders where there are in each of those folders some images. We said we will work with Lego superheroes, and this is something like those Lego minifigures is something that AI haven't seen, right? This is not a standard thing to train AI with. So we are doing something custom, and you can see we have 5 superheroes over here. We have Batman, and that should be our Batman over there. We'll see it when we download. Green Lantern, Harley Quinn, Robin, and Superman. And we have one folder, tests. So I suggest that you click download and download this as a zip. Since those are images, it will take a few seconds to download it. I think it's around 20-30 megabytes. Maybe a bit more, but it should be done soon, 40 something. So we can see it's in our downloads. I already downloaded it earlier, and it's extracted over here. So we have some master folder. Inside of it, we have those 4 folders: Batman, Green Lantern, and so on. And here you can see those are our pictures. Right, that's a Batman summer edition, since it's summer, right? So I hope you downloaded the repo, and now we will go into the custom vision, and we'll start working and creating our models. So you need to sign in. In order to use it, you need free Microsoft account. I will sign in. And what you see in front of yourself, there is some dashboard. And over here, you can see the list of projects. You can search those projects, choose a different type for the project, and like, is it the classification? Is it object detection? And you can select different based on different resources. At the moment, I have an option new project. If you haven't used it before, you also have this new project. And I have 2 old projects where I was just preparing, making sure the things for today's session will work. So this is how it looks like. If I remember correctly, if you don't have any other projects, there will be small arrow showing start over here. So you need to click the new project, and we will start creating project and give it a name that is Azure AI Day. We can enter some description. We can define resource over here. If you have some resources, they will pop up in a drop-down list. If not, you can create new and give let's call it AI Day Test. You give it some name. You choose the subscription. Mine is pay as you go, and we choose resource group, or we can create some new resource group. So let's call it AI Day Test RG, like resource group, and we can choose the location of that resource group. So let's put it into North Europe. That makes most sense. We created a resource group. We can select it now. And over here, under the kind, we will use cognitive services. Once again, we can select location, North Europe, and we can select the pricing tier. So when we create resource, it will take a few seconds. We can create new project, and for that project we can choose, do we want to do classification or we want to do object detection. Classification will tell you in the image the most represented object is that something that can be recognized. For example, this picture is a dog, this picture is a cat. Or if you're detecting fruits, this picture is banana, this is orange, right? And object detection works on a way that I showed you over here in computer vision, like this object over here, that is some train, right? So let's start with the classification because it's the simpler one. And over here for classification types, we can choose multi-label and multi-class. Multi-label can be used when there is in one picture like both cat and dog. And multi-class is used where there is single tag per image, like image of a cat or image of a dog. Our images that we downloaded are prepared like this, so we will use that option. Under domains, we can choose some predefined domains like a general, food, landmarks, retail, and some compact versions. What it is about, you can click learn more and go to the documentation to check it out. So you will see that this generic domain is optimized for a broad range of images classification tasks. Food is mostly optimized for photographs of dishes, landmarks, retail, and so on. And compact domains, those are used for real-time classification on edge devices. There are really nice tutorial and quick starts over here you can check on your own. So I suggest you to do that. We will choose general domain and we will click create project. In a few seconds, you should be able to see the project dashboard. At the moment, like this biggest message on the screen is telling us, looks like you don't have any images here. So first thing we need to do, we need to add some images. We click add images, and in our downloads folder, in files we download from GitHub, let's say we want to take Harley Quinn, for example, as a first set of images that we will import. So open that folder, select all images, and click open. Pop-up will appear showing you thumbnails of the images, and at the moment you are in this view able also to define tag for these images. Tag can be positive and negative. Actually, this positive you can give it some name that makes sense. So this is Harley, right? So we are tagging all those images with tag Harley. We are telling tell our model that this is how Harley looks like. We click upload 9 files. Files will process and summary is shown. So image is uploaded successfully, and over here you can see those images. That is the Harley. You can see the tag on the right. We entered it and showing like on this image there is a Harley Quinn. The thing is, maybe you can notice over here, I took a photos with my mobile phone, and I took the photos on this Lego book with different Legos, and I did it for a purpose that there is some difference between background and the object itself. So AI can figure out better the difference between, okay, this is something that I'm looking for, right? And now we have images that are tagged with Harley, and we want to add some other images. So for example, we will pick Green Lantern. Select images over there, open. And now in this step, we will say that those images are negative. So this is not a Harley Quinn. We are trying to make classifications, so it's only that superhero recognized. We upload those files, takes few seconds. Before the summary is shown, 9 images upload successfully. We click done, and we can see those images over here. Okay, so we added the images. We can see over here tagged images are currently selected. Those are our tagged. Untagged, we don't have any images. In our tagged images, we have images that are Harley and that are negative, not Harley, right? We can now train our model. Big green button top right, we click to train. We choose the quick training and click train. We could also do the advanced training here, but we will do the quick training and quick tests just to get the result quicker. This also means that our prediction result will be lower. So you can train the model several iterations for a long time, then you will get better results. Also not necessarily always, because there is something called overtraining, but like that is another story. So when we finished our training, we see some results shown over here: precision, recall, AP. I'll explain this a bit later, and we see some performance per tag shown that we have some negative, we have some Harley, like 9 images that were trained. And this is it. Like, our model is ready to be tested, right? So we can do a quick test. We can upload image from URL, or we can browse for local files. Let's browse for local file, and let's go into Hero Batman. And if I select picture over here, open, the model will try to figure out, is it Harley or not? And it says, yeah, I am 99.9% positive that this is not Harley, right? So we could test it with different images and figure out, okay, yes, this is Harley, this is not. This works in some cases, but like if you need something more advanced, you will probably go for object detection, because object detection is able to tell you in the picture where this object is and can tell you some other things. So I'll close this one, go back to our dashboard. Now we can see that we have our project appear over here. This is classification. Now we will create a new project that will be object detection, and we will go a bit deeper into the results. So create again a new project. Let's call it Azure AI Day object detection. We can select some new resource or select some existing resource or create new resource again. And in project types, we will now choose the object detection. You see now that the below part of the page changed, so we only have to, in object detections, to choose the domains. Similar thing like with the classification. Over here we have a general domain, we have logo domain, like if you're trying to detect some logo in an image, and we have product on shelves because this is used a lot, and then we have those compact domains. Same thing, you have learned more in case you are not sure which one to pick and which one will work the best for you. Object detection, general, and we create the project. Okay, so we are back into the dashboard. Looks the same, right? But this time we are talking about object detection. So first thing, we will add images, and let's take Superman this time. In the folder Superman, there is one additional subfolder. Just select those 9 images to start with. So we are starting with those nine images and click open. We will upload those 9 files. And summary appears when it's done. So what we see now on the left, we have a red mark on untagged images, which means those images are not tagged. And we need to repeat process similarly as we did it earlier. But this time, when we click on the image, we will have to mark the region like where is the object in our picture. The thing is, Microsoft has this nice AI in the background, which is already suggesting, yeah, I suppose there is some object over here. You can click on that and you can adjust this frame to fit the image. I have some problem with my resolution, so I think it will be better like this. Yes. I will try to mark the Superman as best I can. And I will add the tag that this is Superman. I enter text, click plus, and you can see this is marked as Superman. You can click again on it and edit if needed. Arrow next, you select next picture, and you repeat the process. We need to go through those pictures and manually tag them. It's pretty simple and really quick, even though it's manual work. Few years ago, I was tagging some images manually through the code, I would say, like that, and that was a lot of work to define the points in the picture and such. So this is a nice little UI you can use. It's not super precise, but it's precise enough to select the object. In this case, picture is a bit darker, so it obviously didn't figure out the position of the Superman, so I'll mark it manually, just selecting the area where it is. And we go through the rest of our pictures. This one was precise. I'll just adjust it a bit. And after you are done, there's no more arrow on the right. You can close this view, and you see that in untagged you don't have any more images. So switching here to tagged, those images will appear. I hope you managed to follow this and define your Supermans. And first thing you will notice over here, like, okay, we have images, we have defined where the Superman is, so we would like to train. You will notice that there is a limitation. I'll say quick training. There is a limitation that it needs at least 15 images for every tag. So keep this in mind. This is a really minimal amount of data. With 15 images, results will not be great, but it will be fine enough for you to say, okay, yes, this makes sense. So how we extend our data sets? We have 9 images here, right? We just click on the add images. We can go to additional folder, and we can select, we have 9, we can select 6 more. And we click open. Upload those 6 files. We are done. We see those files are untagged now. So we need to open them again. Select them. I'm moving to next, trying to select Superman over here. And this is the last one. So now we should have minimal amount of images defined, 15 images over here in our dataset, ready to be trained. We took the 9 from the Superman folder and 6 more from the folder additional, and now we will click train. We are still using quick train, and first iteration is starting. It takes a bit longer than classification, but should be done under the minute probably. while we are waiting, this is how result will look like. So we will see those three graphs with values, and there are three values: precision, recall, MAP. It's still training. So precision. This number will tell you if a tag is predicted by your model, how likely is that to be right. Recall, this number will tell you out of the tags which should be predicted correctly, what percentage did your model correctly find. And MAP is mean average precision, and this will tell you like overall object detector performance across all the tags. As you add more tags over here and such, these values will change in first iteration. It usually looks like this, that we have 100% on such a small and simple data set. So what we did now, we entered 15 images, made the object detection model training, and now our model should be able to say in some picture, okay, I see Superman over here. Let's give it a test, quick test, and now let's choose a local file. And let's try to go to the folder tests. And over here we can choose a test one. Click open. And we can see there are a lot of things detected. So we got like 2, 4, 6, 8, 9, 10 bounding boxes showing this could be our Superman. If we take a look at our predictions over here and just move our mouse over the prediction, we can see that Superman currently is detected with 74.3%. Some other objects on the page are also detected, but probability is much less. So there is something that reminds AI this could look like a Superman, which probably makes sense on Robin, for example. It's not so much different. Like if you take a look at the shape of the object, it's pretty much the same. But still, it's under this one is 40%, and this is the highest value. So model, even with such a small amount of images, only 15 images, is able to say, yeah, this looks like that. So how could we improve this model, right? By adding more data to it. And for this purpose, we have a first thing called tab predictions, where we can go. And we can see images that we used for our prediction. And here we can open the image and we can say this is correct one, right? And you can also adjust the frame a bit if needed. So we tell our AI, we verify the result and say this is the correct result. And this image will be taken for future trainings, and our model will try to learn also based on this image. So let's close it. Our predictions are now empty. If we open the training images, we see that image here on the first place. It appeared over here, so it's taken in consideration, and we can also train it by adding more images. So if we go to our Superman folder and go to additional, we can add few more from here. Even though we are still working with a small data set, but we are trying to make some better prediction. We will add Last time we added 6. We will add 4 more. So 7, 8, 9, and 10. We're opening those images, uploading them. They're uploaded, currently untagged. We go through the same process again. We try to adjust our frames so our detection is more precise. And the last one. Close it. No more untagged images. Everything is tagged. So now we added 4 images and we added 1 more from our predictions that we use for training. We click train and select quick training and train our model again. You can see now it's the second iteration and it's currently training.
Can I ask a question, Goran?
Sure.
So once you train now, the probability is that it will have a higher accuracy. Would it be able to test this on a, let's say, a real Superman picture from the net or something?
Yeah, maybe because of the logo on the chest, it would recognize something like that. But otherwise, it would, yeah, the face is not so similar and such, like minifigure shape and human shape, like is a bit different, right?
I actually tested this custom prediction with my daughter's My Little Pony horses. The 3-year-old, she has her own names for the horses.
Okay.
And I always said wrong. So she got angry at me. So I tried this one.
Yeah.
The issue was getting all the pictures because I gave that test to the daughters.
Yeah.
But yeah, it's a really nice one. So this training, it depends on the amount of pictures.
Yes.
Can you scale this so it goes faster?
Yeah, you can, but would be take now some explanation. Like instead of quick training we are using at the moment, you can select advanced training and then you can select how you want to scale it actually and define everything in details over there. Yeah.
And from consumption wise, you pay per training or you pay per model?
The per training, and that can be seen once we select advanced training and then we select define the training budget and how many hours we want to spend into this training, and yeah, you can put several hours and such. Like you can do more in Azure portal over there than you can do in this UI, but this is like idea behind this interface is let's do the training with zero code. Like let's not everybody needs to know. Not everybody needs to be data scientist, AI scientist as such. Let's bring AI to everyday people.
Yeah. Yes. Okay. Thanks.
No problem. Okay, so we trained our model again with new pictures, and we can try to test it again. I took some different pictures, just a few of them in that folder. So I have some test 2 where there is a lot of minifigures. And over here, Superman is over here. It's still got the highest probability, but some other pictures are similar, right? Some other minifigures are similar. I guess it's the face and hair shape, so that's why it got the pretty high score. But with the high score, we are still correct. And if we try, for example, something else like this test 3 I have over here. We can see that actually Harley Quinn is identified as the highest score. And this could be because it's closest, Superman is behind, and it takes some more training probably to get this right. Like you need more images to do so. And since we got this idea, I'll also try to do it quickly to get the Superman picture to see what happens. We can test with that. I guess I can copy link to this picture. And if we do a quick test, well, looks like it works. So yeah, I guess the body shape is similar, like it's red cloak and blue sleeves and legs and sign, and there is a head, so probably recognize, okay, this is something similar, even though if it's not the Lego picture. I was expecting it would be much lower score, but yeah, nice to test like this. Similar like this. These examples we are looking at some time ago. I wrote one blog post that I would like to show quickly, and this was about like where's Chewie and Lego minifigure of Chewbacca, and there was this same idea, but I was using the whole board to try to test it out, and in the project that I defined, I selected its object detection also for the general use, and I also tested it, trained it with a quick training. So results could be higher. I had also small amount of images at start to try it out, just 17 images over here. Did tagging, quick training, and results were not so good. Like it managed to identify some figures on the whole board. This is complicated because board had like 50 or something like that minifigures. So it was hard to find the results. But then I took those predictions and added more pictures, trained it again, did several iterations of it, and after some time it managed to find the correct minifigure. So it managed to find Chewbacca on this board. I will add the link to the GitHub repo. It's not there at the moment. It's only linked to events. So if you want, you can check out this blog post just to extend this knowledge. You can also take a look at the other superheroes we have over here, and you can add them to the model and do some other training. If you want for the object detection to have multiple tags, you can add images. For example, I'll just show quickly. We can add Robin. We haven't used it. Let me just select like 3 pictures. I upload them. Okay. So I can now select this minifigure. And this is not a Superman, right? So it's Robin. And over here, I'm able to add another tag, which is Robin. And I can move on and define it for the other pictures also. Second one, this is Robin. Robin. So in our tags, we can see we have 3 Robin pictures, 20 Superman pictures, and then we will need to add 12 more for Robin for this thing to be able to train. 15 is a minimal data set, as I said. Even though it might sound, yeah, it's not guessing pictures so correctly, but with such a small amount of information we gave to this model, like only 15 pictures, it was still able to predict, and we were still shown how to improve those results and how to train it better. And all this was done without any line of code, right? You're just using AI and you're training your model, and then you can use this model to do some prediction with it and such. You can also go to the settings, and over here you can see the endpoint where you can call your model resource and you can try it out, or you could go also to the portal Azure and see this resource you created and resource group over there that it's ready for use. Find the subscription keys and such. This would be it. One more slide was left with the results. That's what we've seen. So I would like to say thank you, and feel free to connect. My Twitter handle is GVUKSIC, and I'm active on LinkedIn, Goran Vuksic. And yes, if you have any questions, feel free to ask.
Great. So thank you, Goran.
Thank you.
This was nice. So now you can find Superman in a crowd.
Yeah. I mean, those are like basic examples with toys and such, but like what Microsoft gives us out of the box is to use really AI in any kind of applications, and we should be adding that. For example, if our application is able to upload image.
You can just stop the presenting.
Ah, okay. Yeah, it's fine. Over here.
You can leave it there also.
Stop sharing. Yeah. Yeah, but those cognitive services, for example, if application is able to upload the image, we can check for the, like, is it appropriate image for our application? Is it like if you are expecting user to upload the portrait, the face for profile picture, we can check is there a face in the image, and so on. There are so many possibilities with this, and I see that every day people are building cool stuff, so it's really nice.
That's great. And yeah, people can follow you on Twitter, and you blog on the LinkedIn, I see. And
yeah.
You also Medium, and
yeah,
they can reach out.
Of course.
I put in the chat that you will join the extra session if someone has any questions.
Yeah.
So I'll let you join that meeting room.
Yeah.
And I'll set up here and bring on Luis as our last speaker for the day. Perfect. Thank you, Goran.
Thank you.